Okay, we first look at the problem 7.3. So the question asks, says that there is a uniform random variable x. It's uniform between 0 and 1. And we want to use the probability distribution function method or technique to find the PDF of probability density function of this y equals to square root of x. Okay, so since we know that the x follows a uniform distribution, so x must be between 0 and 1. So the square root of x, which is y here, must be between 0 and 1 as well. So we know that this is where the y can take a positive probability. So there should be no probability densities outside of this interval. Now, to use this distribution function technique, remember that for any little y, we need to find the cumulative distribution function or probability distribution function of that y. So this is the cumulative distribution function of y at this little y here, any value between 0 and 1. So by definition, it is just a probability that's random variable y that is less than or equal to this little y. But on the other hand, we know that y is just the square root of x, so we just simply change that to this. And then square root of x less than or equal to y is equivalent to x being less than or equal to y squared. So that's why we change this. So now the probability of this guy here is just y squared. The reason is x is uniform distribution, right? So if I look at the distribution of x, that's 1, that's 0. This is the 1, right? So this guy here is the distribution of x. So the probability that the x is less than or equal to y squared is just this area, which is still y squared, right? It's just y squared. So that's why we figured out the cumulative distribution function of y. So the probability density function of y is just the derivative of the cumulative distribution function. So that's just this, and take derivative of just 2y. And remember that here we figured out that the y has to be between 0 and 1, so the y has to be between 0 and 1. And we know that this guy here is 0 outside that interval. Okay, so in summary, we know that the density function or the PDF of y is just this.